Okay, in this video we're going to look at how to calculate the different components of a mixture. Let's start with this basic example here. How many moles are in each of the components? Recall that there were 55 grams of water and 45 grams of NaCl. So this is actually a continuation of the reading that you did prior to this video. It showed you the steps of getting the different grams of each of the components based on their percentages. Now what we're going to do is we're going to take this one step further and calculate how many moles each one of these components contributes. Because in reality, we're more concerned about the moles than anything. So let's start with H2O. Now we're converting grams over to moles. Alright, this is something that you should already be very familiar with. And in order to do that, you're going to need the molar mass. In this case, I went ahead and gave the molar masses for you, but you should know how to calculate them already. And as a matter of fact, I assume you know how to calculate molar mass. So let's start with the water. In the previous reading example, we determined that there were 55 grams of it. Okay, we want to know how many moles that is. Well, we got to multiply by a fraction, the conversion factor, which is the molar mass of water. We need the grams on bottom so that these can cross-cancel. And then the mole has to be on top. Because it's gram with a mole, you already know that the mole always gets 1, and the grams of the molar mass, and that's 18.82. Again, grams cancel. So we've got 55 divided by 18.02, which means two significant figures, there are 3.1 moles of water in this example, or in this mixture here. Now for the NaCl, same thing. There are 45 grams available, and we're converting those to moles. Again, same idea, and the molar mass is 58.44 for sodium chloride. Grams go away. 45 divided by 55.44 comes out to be 0.81 moles of this mixture is made of NaCl. So this is just another way that the AP test could extend a problem beyond just basic percentage calculations. Let's look at a couple of more complicated examples. For this next one, we have a 235 gram mixture of copper 2 sulfate and water is prepared such that 25% of the mixture is copper 2 sulfate by mass and 75% of the mixture is water by mass. How many moles of CuSO4 are present in this mixture? So I want you to think back here, okay? It says that the total mass of this mixture is 235 grams. That is, if you add the weight of copper 2 sulfate and then the weight of the water together, that will get you the total of this mixture, okay? If we take the percentages and multiply it by the total, that will give us how much mass that in particular part contributes to the overall total mass, alright? So for instance, it said that 75% of this mixture is made of copper 2 sulfate. That means 75% of 235 grams total is copper 2 sulfate. So we figure that out this way. We know that 235 grams of this mixture is the total mass. If we multiply it by the percent that is made up of copper 2 sulfate, which is 75%, in this case in its decimal form, we have to put it in its decimal form, this will tell us how many grams of this mixture is copper 2 sulfate, or the CuSO4. Let's go ahead and do that. So 235 grams times 0.75 means that there are 176.25 grams of copper 2 sulfate in this mixture. Okay, but the question asked how many moles of copper 2 sulfate are in the mixture. It didn't ask for the grams. So guess what you got to do? You've got to convert those grams into moles using the molar mass, just like we've done before. And in this case, I was kind and for the sake of time gave you the molar mass, but you will have to calculate it on your own unless the question gives it to you. And again, I assume you know how to do that. So grams to moles. We know we have 176.25 grams of CuSO4. To get those over to moles, we need to divide by the grams. That'll take us to the moles. And the molar mass is 159.62. Let's go ahead and calculate that. 176.25 divided by 159.62. That means there are let's see, we have 4 significant figures. No, 5. 1, 2, 3, 4, 5 significant figures. So that's going to be 1.104 moles of copper 2 sulfate are in this mixture. Okay. Let's look at a little bit more complicated example. Okay. A mixture is made up of hydrogen peroxide, H2O2, and water. 97% of the mixture is water, which comes out to 85 grams. What is the total mass of the mixture? Okay. So thinking back to it again, we know that the total mass is going to be the grams of this hydrogen peroxide plus the grams of the water for this mixture. Unfortunately, it didn't give us any information about how much mass of H2O2 there is. It only gave us information pertaining to the water. Okay? And in fact, it said that there are 85 grams of water in this mixture, and that of those 85 grams, that's 97% of the total mixture. If you think back to percentages, ladies and gents, recall that if we take the part of something, divide it by the whole thing that that part came from, and multiply it by 100, that'll give us the percent that that part contributes. We know what the part is. That's the 85 grams. We don't know what the whole is, but we can figure that out because we do know how much percent that contributes. Okay, so the part and the percent, we just don't know what the whole is. Okay, but that's just one variable. We have everything else in place. So we can now set this up in the formula such that 85 grams divided by the whole, which we don't know what it is, that's the total mass, we'll just call it X, times 100 is equal to 97%. Okay, and we can now use this formula and a little bit of algebra to solve this problem. And now I'm going to go ahead and erase some of the stuff up here and then move everything up so that I have more room to work. Okay, now we need to do algebra. We're solving for x, so we need to isolate the x by itself. The best thing to do is to first divide everything by 100 to get that 100 over to the other side. Okay, that means these will cancel. You're left with 85 grams over x is equal to 97% divided by 100 is the same thing as moving the decimal place over 2 places. So this becomes 0.97. Now we need the x to be on top. So what we would do here is we would just go ahead and flip both sides. Okay, let's just literally flip this. Right? But if we flip that side, we also have to flip the other side. Now this is technically over 1, so we will flip this as well. Now it's 1 over 0.97. We now have to get the x by itself, so we'll multiply both sides by 85 grams. And that means x is going to be equal to 85 grams over 0.97. And if you put that into your calculator, that means the total weight of this mixture was 87.26 grams. Okay. Alrighty, ladies and gents, these are just one of the very many ways that we can do parts and percentages in AP Chemistry. In the next two examples, you'll review examples similar to this and one a little bit more complicated.